Here's what's happening worldwide. So this is global consumption of sugar and sugar crops. Here we are at 629 calories availability here in blue. And here's the rest of the world. Now, the American Heart Association says 150 to 200 calories in added sugar per day, right here, this color, blue. How many countries are above that? How about all of them? In fact, that's why diabetes is skyrocketing everywhere. So here's world sugar consumption tripling over the past 50 years. Per capita consumption, notice Brazil. Brazil used to be a poor country. They were always a sugar exporter, but they couldn't afford their own sugar. But now they can because they're a brick country, right? They sell Embraer jets and biodiesel and, like World Cup, and all that stuff. And the fact is that Brazil now has the highest increase in rate of prevalence of type 2 diabetes in the world. Doesn't have the highest prevalence. That's reserved for Saudi Arabia, Kuwait, United Arab Emirates, Qatar, and Malaysia. Why them? Why do they have the highest diabetes rates in the world? No alcohol. No alcohol. But they got soft drinks like they're going out of style. Why? Because it's hot, and the water supply is a question mark, and no alcohol. This is their reward. Now, the difference is alcohol, for lack of a better word, is self-limiting because you end up under the table. But soft drinks, you can drink them all day, right? And they do. So during the decade, diabetes prevalence rose from 5.5 to 7% worldwide. Not good. And here's the effects model. Sugar, sugar plus controls, plus period. Bottom line, remember that diamond? It can't cross the identity line? Well, it doesn't. It's very significant. In fact, for every 100 calories, you increased your diabetes prevalence worldwide by 0.8%. And here's the adjusted association when you took all the factors into account between sugar availability and diabetes prevalence. Here's what you need to take home. This is the take-home slide. Only changes in sugar availability predicted those changes in diabetes prevalence worldwide. Only. If you consumed 150 calories extra per day in total calories, diabetes prevalence only went up by 0.1%. Nothing. But if those 150 calories happened to be a can of soda, diabetes prevalence went up 11-fold, 1.1%. And we're not consuming 1 can of soda per day, we're consuming 2.5. So that's 2.4%. Given that American diabetes rates are 8.3%, that means that 26% of all diabetes in America today is due to sugar and sugar alone. Not due to obesity, not due to total calories, sugar and sugar alone. You want to do something, you want something actionable, you want something that's going to change how much money we spend so we can salvage Medicare? Here it is. And of course, our government is doing absolutely nothing. Okay? Our data show that 25% of diabetes worldwide is explained by sugar. And more importantly, this is causation. Because these data meet what's known as the Bradford Hill, the Austin-Bradford Hill criteria for what we call causal medical inference. Now, what does that mean? It means that you can show dose effect, you can show duration effect of sugar on diabetes, and you can show, most importantly, directionality. That is, those countries where sugar went up showed an increase in diabetes rates. Those countries, the few of them where sugar went down, showed decreased diabetes rates, and precedence. 3-year time differential. So every country, when their sugar went up, 3 years later you saw the change in diabetes in either direction. That's causal medical inference. The question is fast food addictive? What do you think? Yes. Yes? No? What do you think? Yes. Okay. Well, so we actually looked at that question. So everybody familiar with this book? Yeah. Michael Moss put this out. Salt, Sugar, Fat, How the Food Giants Hooked Us, right? Yeah. This is wrong. This is a mistake because there's one thing not on the list. What's missing? Caffeine. Now we've got fast food. Okay, salt, sugar, fat, and caffeine, right? So the question is, of these four, which are addictive? Let's talk about salt. Is salt addictive? Nope, it's not addictive. In humans, the threshold is physiologically fixed. Higher levels are attributable to preference, but you can alter that preference. Lots of people do, especially when they have to go low salt for some reason. And we know because we take care of a disease in endocrinology called salt-losing congenital adrenal hyperplasia, where their kidneys are losing salt nonstop. But when we give them the salt-retaining hormone that works in the kidney called aldosterone, their salt intake goes way down. And if they were addicted, that wouldn't happen. So when we fix their physiology, their preference gets a lot better. So salt, not addictive. Now let's take fat. Is fat addictive? What do you think?
No.
Nope. Rodents binge but show no signs of dependence, and in humans, they always binge on high-fat, high-carb, or high-sugar items, like pizza and ice cream. You don't binge on high-fat per se. Otherwise, the Atkins diet would have everybody addicted, and they'll tell you, they're losing weight. How could they lose weight if they were all addicted? Energy density actually has a stronger association with obesity and metabolic syndrome than fat does. So, fat, not addictive.